Hi everyone. Today we're going to be working on number 9, Jackson Pollock's data table, and this is going to be our last question for the fall 2022 CS88 midterm exam. All right, let's get into it. So in this problem, we will be creating basic data tables, which will allow you to add, delete, and access columns. You may remember the tables that were used in Data 8 or from Excel and Google Sheets. And the table will be represented as a 2D array with the first element being a list of column names, like a header row. Subsequent elements will be lists that represents the values in the row. All right, so something interesting that we have to note is that we'll be working with 2D arrays. All right, and elements will be lists that represent the values in the row. So we want to complete the functions, create table, add row, delete row, num rows, and get row. And there's also another note that we'll be working with abstract data types. And our hint says that we might want to use list functions append and pop. And just for a quick review, append adds an item to the end of our list, and pop removes an item at the specified index from the list. All right, let me change the color. And let's get into our problem. We have our first function, which is create table. Taking a look at the doc test right here, we see that T is assigned the value of create table, product, inventory, and price. And when we call T right here, we see that we're given, this is a result of, we are given a 2D array with the 3 items. And one way the way 2D arrays are represented is through these double brackets. Okay. So as a result, when we return, we can just turn a list with the value of columns. And this is because columns is given as a list already, so we don't have to kind of create the 2D array. We just have to insert columns into our list. Okay, so for B, we want to add row, and we're given a table and a row. And we can assume that the number of entries in the row matches the number of columns in the table. So when we add, this action is corresponding to the idea of appends. So using our hint, we can implement appends into our return statement right here. And we have table, and this is what we're adding the row to. So we will return table dot append. And what we want to add to the table is the row that we're going to be given. All right. And then we're going to be doing part C now, and it's delete row with our given table and an index as well. So we want to delete the row at the index, and the row of the column titles does not count in this indexing, and the table is 0 indexed. And so what does this mean? It means that, remember when we called T right here, we saw that the 0th item in this 2D array was, the first is the titles of the columns, and then the second was the actual row that we wanted. So when we have this index, it takes into account that our 0th item is our column titles, but we don't want to have that counted for our index when we delete the row. That's why we have to modify the index first before we actually delete the row. And we're going to be adding 1 to the index. And remember, when we delete the row, this action that corresponds to this is actually pop, right? We can use pop in our return statement, and this is why the answer is return, and then we're modifying table. We're going to do dot pop, and then it's index plus 1. Next, we're going to be working with num rows and table. And what this function does is returns the number of rows in the table. And again, column names do not count as a row. So remember, one way we are able to get the number of rows in the table is through length. Why? This is because table is represented as a 2D array, and we can count the number of rows as the length, how long our 2D array is. However, just simply putting length of table will not give us the correct answer because we included the column names, but we don't want to include the column names, which is why we do length of table and then we subtract 1. And then lastly, we have our function getRow. And this returns the row at index and assumes that the user always provides a valid index. And the row of the column titles does not count again in this indexing, and the table is 0 indexed. So we want to get the row of a specific index from our table. And remember, since our table is represented as 2D, a 2D array, we can find the item of a list by calling the name of the list with the item that you want. Let's say I want the 5th, so I just do that. So similar to this idea, we can also use this in getRow by calling table. And we'll also use the index that was given. However, remember that we don't want to account for the column titles. So what we do, we modify index plus 1. Okay, so that's going to be our return statement for getRow. And also, these answers are here in the box as well. Moving on to the second part of this question, part F asks that the following code returns the second to last row from the table TB. Does this break the abstraction barrier? So we see that X is assigned to getRow TB, length TB minus 2. And actually, this problem does break the abstraction barrier. Why? Because we are assuming that length TB minus 2 right here, we're assuming that we are able to find the length of TB. As users of the abstract data type, we don't know the underlying implementation of our ADT. So there's no guarantee that we are able to get the length of TB using this syntax. That's why it breaks the abstraction barrier. For part G, we see here that the following code returns the middle row from the table TB. Does this break the abstraction barrier? X is assigned as num rows TB. This is valid because num rows has been defined in our ADT right here. Next, we assign middle to X with the floor division of 2, and that's also fine because we're just evaluating a statement. And lastly, we have R is getRow, TB, and middle. And for getRow, it has been defined above. We worked on it earlier, and our parameters are TB and middle. We're not assuming anything about our ADT and how to use and the underlying implementation. So this is also valid as well, and it does not break the abstraction barrier. Last but not least, we have part H, and the following code moves the first row to the bottom of the table TB. Does this break the abstraction barrier? So first is using the function getRow, and it's being called on TB and 0. That's perfectly valid. And then we delete the row with TB, and it's the 0th item. That's also fine as well. Lastly, we add row, which we worked on earlier as well. And we have the 2 parameters TB and first. Again, we're not assuming anything about the underlying implementation, so this works, and it doesn't break the abstraction barrier. And that's all for the last question of this midterm, Jackson Pollock's data table.